All right, so we're continuing on with class 15 content, and here's an example of a crank slider. This is Norton's example 6.8, and I forgot to detach my screen here and turn it around and then turn it back upside down. So hopefully that won't mess things up here. Let's see, flip it around. All right. So it'll be interesting to see if that caused any problems. So we will stay in this mode and we'll work through the problem. And let's start out with black. Okay, so what we have here is we have a dimension A of 40 millimeters and a dimension B of 120, and we have an offset, so C is actually down as negative, so that the line of action right here is actually below this O2. And so this angle in the terms of the position is 60 degrees, and omega is a negative 30, so therefore it's going to be clockwise, that omega 2 right here. And let's see. So we want to use the, we want to find the values of omega 3, right? So that's going to be, we want to find which way this is. We don't know whether it's going that way or that way yet. And we want to find the velocity of A, and we want to find the velocity of B. So we take the equation for omega 3, where we have A times the cosine of theta 2 divided by B times the cosine of theta 3. And so that's going to be A is 40, cosine theta 2 is going to be 60 degrees, and B is going to be 120. And we take the cosine, and we needed to do a position analysis to be able to get that theta 3, and we find that it's going to be 152.9. So we get an answer of 5.616 radians per second. And since it's positive, it's counterclockwise, right? So we found this omega 3 from that. In order to get D, and this is going to actually be the velocity of B, is going to be equal to the D dot, we use negative A omega 2 sine of theta 2 plus B omega 3 sine of theta 3. And so that's negative 40 times our omega. By the way, I think I left something out here. Yeah, I did up above. Why'd you let me do that? This should be omega 2 right here, and that should be right there, should be negative 30. I left that completely out. But because we have this cosine of 152.9, that's going to be a negative value, so that negative and that negative generate this value, and that's why that's positive and it's counterclockwise. So we have this input of negative 30 right here down for this one, times the sine of theta 2, which is 60, plus 120, and then the 5.616 that we just got from above, and then the sine of theta 3, which was 152.9. And we get it's 1,346 millimeters per second to the right. Now, we already found omega 3, and we found the velocity of B. So now we could find the velocity of A. Velocity of A is actually going to be, we could go back to the velocity, the vector loop equation and its derivative, and we find that it's A times omega 2 times E to the j theta 2. And by the way, this is actually going to turn out to be something that's like really easy to have found. because all we needed to do was really multiply negative 30 times 40, and that would have given us the answer. But that's okay. We'll go ahead and do this anyway. So we got 40 times our negative 30, and then we're going to substitute for j theta 2, and we know that that's going to be negative sine times theta 2, or 60, plus j times cosine of 60. We end up with 1039, right? And then minus j 600. That's millimeters per second. We take the square root of the sum of the squares and we get 1200, duh, because that was 30 times 40. And that's the magnitude. And then we take a look and we could get the tangent of the thing, but we could actually probably just have looked at it and said, that was equal to 30, because this was 60, and we're going to have this guy right here. This is going to be our VA. So it's obviously going to be 30 degrees downwards right here. We could also, now we could find, if we weren't asked for, we could find the velocity of A with respect to B by taking these two minus each other, right? So we could take this minus, where'd you go? No, we couldn't do it. My bad. Is that true? Yes, no, that's true. No, totally true. We could take, in the x direction, this minus that. And then we're also subtracting out this right here. Right? A little purple here. So if we do that, we end up with, that's going to be VA minus VB. We end up with negative 307. And then, so we go, yeah, it goes A minus, so we get negative J 600. Yep, that's great. Millimeters per second. And we would end up with 674.0 millimeters per second. This direction right here of 62.90. Of course, it's going to be downwards and to the left, because this is in the lower left quadrant right there with a negative and a negative. And 64.0. Okay, we could also, so there's or, we could also use VA with respect to B is going to be B times omega 3 J times E to the J theta 3. And of course, we could take that. It's going to be 120 times our omega 3, which we found up here, is 5.6, 616. And then that's times the negative sign of 152.9. Yeah, 9. Plus J times the cosine of 152.9. And what we're left with is going to be equal to negative 307.0 minus J. And I ended up with 599.9, but we know it's supposed to be we know it's supposed to be 600 because we go back to here and we could see that is definitely right here and right here is going to be the same thing as here, right? Because the important thing as part of this, and I don't have it written anywhere. Okay, the important thing in this vector loop equation that we had, if you'll recall, for the crank slider is, I'm going to go to my pen, don't I? And in my pen, I want to go that as we're taking a vector loop of the thing, and we're taking a e to the j theta 2 minus b e to the j theta 3 minus c e j to the theta 4, and then it's going to be minus d equals 0, right? We end up with a is a omega 2 j e to the j theta 2 minus b omega 3 to the e, nope, I need a j in there, j e j theta 3, and then this guy right here doesn't change, so he goes away, and then it's minus d right here, because this guy gets longer and shorter. So remember that this is going to be that this is the velocity of b right here, and this is the velocity of a right here. So this is the velocity, I said acceleration, this is the velocity of let me see, like I say, it's going to be equal to 0, so that's going to make sense that this is going to be a with respect to b, right? So when we're taking a look at this, well, they're showing this to be b with respect to a, but it makes more sense to me that we're actually right, and it's going to be this velocity right here that we're going to take a look at, because it's actually, anytime we would do this, by the way, this right here would be the velocity of a with respect to b, that they would be backwards. But we notice that these are what each of these things are their variables. And I mention that because I think it's important to recognize what the vector loop equations and how they're tied into each of the values of this thing. This piece right here, this connecting rod, is translating and rotating at the same time, and so it's a combination of the two, and so it obeys either it obeys that. So I'm going to put this into I'm going to discard this, and let me look at the time. It's a 12-minute video. Let me go ahead and make it into a separate video for the Excel. So I'm done right